Hello, today we're going to be discussing section 6.2, which is on representations of functions. Our essential question for the day is how can you represent a function in different ways? Our key idea, functions as equations. A function rule is an equation that describes the relationship between inputs and the outputs, or for our purposes generally, we call the inputs x and the outputs y. So we're describing a relationship between x and y using an equation. Functions you can often think of just as a machine. If you put the same thing into the machine, you should expect the same output every single time. Your machine shouldn't be changing when you put in the same number. So for example, if I put in the -2 to this kind of function machine, I should expect to be getting the same output of -6 every single time, regardless of how many times I put that -2 in. So if x equals -2 in my equation, y equals -6 every single time. A function rule is just another way for us to describe an equation. So in example 1a, we're going to write a function rule for the output, which is y, being 5 less than the input, which is x. Now this phrase 5 less than is a little bit tricky because less than actually means we need to start with a value and subtract from that value. For example, if you think about if you have 5 less dollars than me, and I have maybe $12, we can figure out how much money you have. And how we would do this is we'd say, I have $12, you have 5 less than me. So we're actually going to take my 12 and subtract the 5 after the 12. And that's exactly what's happening here. The output is 5 less than the input, meaning we're going to start with the input and subtract 5 from there. Now the output is or equals that x minus 5, and this would be your rule for your function. 1b, we're going to write a function rule for the output y is, which means equals, the square of the input, which is x. Square just means we're going to raise this to a second power. So y is equal to x squared, or the square of x. What is the value of the function y equals 2x plus 5 when x is equal to 3? So we're now going to think of your function machine. We're going to put in a 3, so our input is 3. Our function machine says y equals 2x plus 5. So our 3 goes into this machine, and out comes our y value, which is going to be 2 times 3 plus 5, or 11. So the value of the function is 11. Go ahead and take a moment to pause the video and try the next 4 on your own. Our output y is 1/4 of means multiplied, so 1/4 times. X is going to be the rule for our function here. When x is equal to 5, y is equal to 4 times 5 minus 1, so y is equal to 19. So the value of the function is 19 when x is 5. Here, the value of our function is going to be 50, because 10 times 5 is 50. And lastly, when x is equal to 5, y is equal to 7 minus 15, so y is equal to -8, meaning the function value is -8. We're going to graph the function now using the inputs that are given. So we're only going to input these values, -1, 0, 1, and 2 for x, figure out which y values we get, and then sketch our graph from there. You might remember doing something like this from a simple t-chart. I can input -1, 0, 1, and 2, and then determine the y values from there. So when x is negative 1, y is negative 2 times negative 1 plus 1. We get y is equal to 2 plus 1, or y is equal to 3. When x is 0, y is equal to negative 2 times 0 plus 1, which gives us just y is equal to 1. When x is 1, we've got negative 2 times 1 plus 1, so y is going to be negative 1. And lastly, y is equal to negative 2 times 2 plus 1 when x is 2, giving us y is equal to negative 3. And from here, we're just going to sketch a quick graph. I've got negative 1, 3 as my first point. My second point is going to be 0, 1. Third point is 1, negative 1, and 2, negative 3. So your graph looks something like this, and we can go ahead and draw a line to connect our points. Go ahead and take a moment now and practice graphing the next 3 on your own. You may pick whichever inputs you would like to use. For this first equation, I'm going to pick negative 1, 0, and 1 as my inputs. Y is equal to negative 1 plus 1, which means y is equal to 0. Y is equal to 0 plus 1, which means y is equal to 1. Y is equal to 1 plus 1, which means y is equal to 2. And when we sketch our quick graph, I've got negative 1, 0, 0, 1, and 1, 2, so our line will look something just like this. For the next graph, I'll go ahead and just sketch a brief picture of what your graph should look like. So you should have a point at the origin, a point at 1, negative 3, and negative 1, positive 3, and when you connect your dots, your graph will look something like this. And lastly, you'll have a point at 0, 2, and then if we count from there, you should have a point at 1, 5, and you should have a point at negative 1, negative 1. So your line should look something like this. Now, of course, your lines might look just a little bit different, or at least your points might be in different locations depending on which inputs you chose for your graphs. But regardless of which inputs you chose, your lines should look the same as the lines that I have drawn here, as long as you extend your lines far enough. Example 4. The number of pounds in carbon dioxide produced by a car is 20 times the number of gallons of gasoline used by a car. Write and graph a function that describes the relationship between G and P. So the number of pounds P of carbon dioxide, so we can kind of scribble all of this out because this isn't going to help us write our function. All of this is, which means equals, 20 times the number of gallons G, so 20 times G of gasoline used by a car. So what we've just kind of narrowed this down to is P is equals 20 times G. All of that other information about gallons and carbon dioxide is just excess information that we don't need for our equation. So we have our function, and now we're going to go ahead and pick some inputs and graph. Again, I always think that negative 1, 0, and 1 are the easiest, so I'll go ahead and use these. Negative 1 gives me negative 20, 0 gives me 0, 1 gives me 20, and I go ahead and graph. For the sake of the graph, I'm going to go ahead and count by 10. So this is 10, 20, 30, 10, 20, negative 10, negative 20, negative 30, and negative 10, negative 20. So I've got negative 1, negative 20, so that's going to be right about here, pretty close to that y-axis. 0, 0, and positive 1, positive 20. I go ahead and draw my line, and your line is going to look something like this. On your own, go ahead and take a moment to pause the video and try this last one on your own. For a truck, we can cross this information out. We're relating this back to example 4. P is 25 times G. So they give us our necessary information right away here. We really don't have much that we need to ignore. So we can go ahead and write our function. P is 25 times G. We'll create our chart so we can graph X and Y. I'll go negative 1, 0, 1 again. So I get negative 25, 0, and positive 25. And sketching a graph, I've got, I'll count by 5s, 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. I've got the coordinate negative 1, negative 25, so that's going to be about here. 0, 0, and 1, 25. It does look very similar to the last graph because our numbers are kind of small for the x values and kind of large for the y values. So it's difficult to tell a difference just based on the picture, but based on the values you can definitely see a difference. And this brings us to the end of our lesson on representations of functions. Thanks so much for watching.